Hello and welcome back everyone. We will start this video by talking about the Numpy package to learn more about processing data and performing scientific computations in Python. The Numpy package provides us with array and matrix objects with a large set of mathematical, logical, sorting, selecting, and basic linear algebra functions to perform on those objects. In this video, we will learn the properties of array objects and practice how to create and perform operations on them. So let's start. The center of the NumPy array is the ND array object, which is an object of an n-dimensional array. This object is not the same as the common Python sequences, such as lists. Let's look at how this object is different. NumPy arrays have a fixed size, unlike Python lists, which are dynamic in size. All elements of a NumPy array have to be of the same type. As NumPy arrays are used to deal with large sets of data, they are designed to perform operations on them in a much more efficient way than using the common Python data structures. The main array class of NumPy is called ND array, which is an array with n dimensions. Dimensions can also be called axes in NumPy. A class is a collection of variables and functions that you can instantiate several objects of. You can study classes as part of more advanced coding courses that cover object-oriented programming in more detail. The first thing we need to do is to import the NumPy library using the import command. Let's create a NumPy array and print it using the following command. Each ND array created has a set of very important attributes. These are some of the most common ones. ndarray.ndim. This command indicates the number array dimensions. In our previous example, the array was a single dimension. ndarray.dtype, which provides the type of data inside the array. Note that NumPy provides additional data types, such as numpy.int32 and numpy.float64, as you can see. ndarray.size. This provides us with the total number of elements that exist in the array. ndarray.shape. This provides us with a tuple that shows the size of the array in every dimension. The length or the shape of the tuple will be equal to the number of dimensions. Let's now create a small example and learn how to use NumPy within our codes. As we saw, the array function transforms sequences of sequences into two-dimensional arrays and further sequences into further dimensions. You can also specify the type of the array when creating, as you can see. If the type is not specified, it will be detected automatically according to the elements in the array. Other useful functions for creating arrays are zeros, ones, and empty. Zero creates an array of zeros with the specified dimensions, as you can see, and ones create an array of ones, while empty creates an array with random content with the data type of float64. We can use the function arrange, which is equivalent to range, to fill the elements of the array with the specified range. This is best used with integer numbers, as when it's used with floats, we cannot predict the number of elements that it will produce due to the finite floating point precision, as you can see. To compact this, we can use the line space function, where we can specify the total number of elements rather than the step size as it shows. In this example, we have specified the total number of elements to be 5. We have now covered the basics of how to create NumPy arrays. Let's move on to the next video to learn about the operations that we can perform on these arrays.